So before we continue, we're going to do a little house cleaning. Like right here, there's too many bangs. There's a lot of stuff changing because the image sort of flickers. And let's see if we can tell this patch that between two bangs, there should be a minimum amount of time. Here, let's find a moment when there's a lot of movement. For example, when there's a fire. Oh, here, this is a good section. The thunder, here. Okay, we don't want it to trigger all the time when there's thunder here. So we want to give it a minimum amount between triggers. And to do that, there's a little trick. There's an object that helps us do that, which is called one bang. So one bang only lets through a bang once. So if we have to give it a bang in here for it to let through a bang out here to the left. And now all the subsequent bangs aren't coming out here unless we give it another bang here. So by using that, we can make a sort of temporal bang filter. Basically, we tell one bang, we give it an argument 1 so that it starts open. It's going to let a bang through. Now, this first bang is going to come through here and go out here. And as soon as it goes out here, all the following bangs aren't going to go through anymore. So first bang came through. Now all the other bangs aren't coming through anymore unless I send another bang in here, and now it comes again, but none of the others. So what we do now is we're going to add a delay, and we say you wait for, I don't know, 400 milliseconds before you bang it here. So when this bang comes out, we send it into a delay, we wait for 400 milliseconds, and we trigger this bang, and now the next bang after 400 milliseconds can come through again, and then we have to wait for another 400 milliseconds for it to come through. So that means if I click once, it comes through. If I click slowly, basically every time I click, the bang comes through. Here, let me pause the video. So every time I click, as long as I do it slowly, it comes through. If I start clicking really fast, it's letting through bangs only at a rate of 400 milliseconds because it always waits after a bang for 400 until it lets through the next one. So that's really convenient for us if we don't want to trigger too many cuts here. So basically we're going to fit this in here before the click, before our big bang. We're going to use this little one bang trick. So this one goes to delay. The delay opens up after 400 milliseconds, and this goes to the click. So a clip will never be shorter than 400 milliseconds. I mean, this value can obviously be different. We can set this to like 5 seconds, for example. So now we're missing plenty of cuts because it'll always wait at least 5 seconds before it makes a new cut. So that's probably too long. I'm just going to set it back to 400, but you want to experiment with this value depending on the footage you're working with, right? Okay, now we're practically there. So we're going to clean this whole thing up. So we're going to make a patch, a sub patcher here. We don't need this click anymore. I'm going to consider that this is working. I guess we don't need these guys anymore. They just use up processing power, which we don't want to waste. I guess we could leave this, but I'll just disconnect it. And now we encapsulate all of this in a subpatcher. So I select everything, I go to edit, and I say encapsulate, and bam, it puts it all into a little patcher which we can call frame difference. So inside this patcher, it calculates the frame difference, and when it detects a big difference, it triggers a bang. So we can still have a JIT-P window here, so we see what's actually happening. Okay, like this. And I guess we can put this back in here. So this is where our patch is, which we just made, huh? It's just inside this frame difference patcher. Great. So now what we need to do is to write new files. So we have this video, we have this patch that sends out to bang when there's a cut, but now how do we create separate files, separate clips out of this sequence here? Well, the central object we need here is JIT-record. JIT-record, well, it records clips, it stops, and to record a clip, we send it the write message. So you can tell it write. You tell it where to write to. So I'm writing tilde/desktop. So it's just going to write the clips onto my desktop. And now we could give it a name. So if I write just one file, I'll call it test file. And we're gonna give it frame rate, 30 frames per second, and a format. So I'm gonna use H.264, which is a codec that's compressed video, basically like MP4 or something like that. Would use this typically, and it needs a video input. So I'm gonna use our clip from up here as the input. Now when I click here on write, it writes the file, and all of this stuff is being written into the new file, and as soon as I click stop, it closes the file. Now when I go into the Finder onto my desktop, here's my test file, which I just recorded. It's called testfile.move, and it stops just when I clicked stop. So that's how it works when you do it manually. And now we want to do this automatically. But if I just connect this here, every time it'll trigger, it will overwrite its name, right? Because it will always have the same name. So we need another object here. We need a counter, just so we have a different number every time this clicks. So we're going to take this big bang here, send it into the counter, and now this will just be an incrementing number. Every time there's a cut, this number will go up. Should go. There we go. Well, that was the first one, so it's 0, and 1, 2, and so on. So this is just a number that will go up. And instead of using this message box write, we'll use another object called sprintf. And sprintf allows us to use variables. So we're going to rewrite our message write tilde desktop, and we can call it well, let's call it test file and underscore, and now we use our variable, which is %ld. So %ld will be the number that comes in here. So the file will be called testfile_16, testfile_17, 18, 19, and so on. Okay, and then we give it, as before, the frame rate, 30 frames a second, and H.264, the format. And basically, if I send in a number here and I look what comes out of sprintf, it's this. Okay, so it's just a message like before, but it adds underscore number, the number that comes in here. All right, and now this number here is going to be the number here from the counter that changes every time there's a cut. Okay, so I'm just going to take this. Now, we're almost good here, but before we write a new file, we need to stop the previous file. So basically, when there's a cut, what we do is we stop the recording of the previous file, and then we send the number into this printf to start writing a new file. So for the very first file, it'll receive a stop message, even though it's not writing a file, but that's no big deal. We'll just get a little error, but that's okay. So we send it stop, and then we send the number that comes out of the counter over here into our printf that writes this message here, and we send that into the JIT record, so it starts recording. And that's it. Now it should be working. There was a cut, and it should be writing a file. Let's have a look over here. Desktop. Yeah, test file. Here we go. There's a new file every time there's a bang over there. It writes a new file up here. Bang, wrote a new file. 61, 62, 63, 64. There was a lot of cuts there. 67. Okay, I'm gonna pause it right here. I'm just gonna go into the Finder and see what this actually looks like. So here's a short clip. Here's the next one. Next one. And yeah, so basically we have a little patch that cuts up our entire movie into individual little clips, which you can throw into a sampler or do other fun things with. Depending on the values you put in, you might get too many clips. Like here, if there's a lot of movement, it just considers it to be a new clip. Or too few, but that's up to you. You just need to get those values right, like here. All right, well, thanks for watching and happy patching. See you later.